Large data networks have captured the attention of healthcare executives and clinicians. They're part of the big data movement and a related specialty, data analytics. Big data is usually distinguished from small data by its volume, velocity, and variety. The so-called 3 V's reflect the fact that the amount of data available for analysis is huge, compared with the quantity of data that has traditionally been obtained from clinical trials and population studies. The databases currently being examined may include petabytes of data, which each contain 1,024 terabytes, or exabytes, which each contain 1,024 petabytes. A terabyte contains 1,024 gigabytes. They may comprise billions of patient records, such as EHR data, social media, claims data, and much more. The databases typically consist of structured data, for example, the ICD, International Classification of Diseases, codes for patients, and unstructured data such as narratives describing patients' signs and symptoms. The speed or velocity with which these data are accumulating and at which they can be moved from place to place also distinguishes big data from more traditional sources of patient information, as does the variety of types of data, which can include input from remote sensors, text data on hard drives and smartphones, and imaging data from videos, photographs, and X-rays, among others. All the data can be saved in different types of storage bins, including relational databases and data warehouses, and analyzed by linking the bins through a process called distributed computing using a tool such as Hadoop. Data scientists also use terms such as semantics, syntax, and ontology, all of which have special meanings in the context of medical informatics. In a simple computer file folder, or directory, you might store information in individual files as Microsoft Office text documents, or PDFs, and images as TIFF or JPEG files. But if you tried to identify relationships, correlations, or patterns between these diverse collections of data, it would be difficult. Relational databases help solve this problem, making analysis easier by creating a schema, which is the structural representation of data in a database. The data are compartmentalized in various tables, fields, rows, and columns, and the database creates relationships among the numerous data points. The database then can be queried to pull out links between elements such as columns and rows. One table may list all of a patient's demographic details, including age, address, gender, and race, and a second may list their family medical history. By querying the database, you might be able to determine, for example, which female patients have a history of a specific disease because linkages between the demographics and family history tables are built into the tool. Understanding the concept of distributed computing is another piece of the puzzle that can make big data less mysterious. In the simplest terms, distributed computing is a way for individual computers to talk to one another and function as one gigantic brain, despite the fact that the machines may be located all over the world.